A lot of people don't realize that you can also use GEMDAS when solving equations, not just simplifying. So let's go ahead and write GEMDAS. And let's talk a minute about what does it mean to solve. Well, I want you to think of solving a mystery. So what do we do when we're solving a mystery? We're actually working backwards to undo the clues. So think of undoing. So we want to undo the clues. We're actually going to work backwards. So let's look at a very common example. So this here is going to be example 1. So let's say that the current temperature, maybe we're in Europe, and the current temperature is 17 degrees Celsius. But I don't know what that means, so I want to know what is that in Fahrenheit. So I want to know how many degrees is that in Fahrenheit. So I have a formula that you may have learned from chemistry, which is Celsius is 5/9 times the quantity of Fahrenheit minus 32 degrees. So when I'm looking at this, I'm going to work backwards. So think of it, what's the simplest thing to undo? Well, adding and subtracting is kind of the easiest thing to do. I can't undo this because this is in a group. So I have to be very careful about that. So I'm going to mark a couple things. I'm solving for F. That's what I want to have by itself. But before I do, I have to free it from its grouping, because that's the last thing that I will attack. So I have to undo this multiplication. So I have to undo the multiplication first. And I want to think about inverse operations. Okay. So a lot of people think, well, if I want to undo the multiplication of 5/9, that you may want to divide by 5/9. But that becomes kind of ugly, because then we have 5/9 divided by 5/9, and then I'll have the C divided by 5/9. There's another way that we can do it. We can multiply by the inverse, or reciprocal, you may know it as that, of 5/9, which is 9/5. That's the reciprocal or inverse of 5/9. That would be cleaner, so we're going to do it that way. So I'm going to rewrite my formula. So I have C is equal to, I'm going to leave some space here, 5/9 times F minus 32. So I want this 5/9 to become a 1, so I multiply it by the inverse. And you have to remember, whatever I introduce on one side, I have to introduce on the other. So this has to multiply with everything on the other side of the equal sign. So by design, this actually divides out to 1. So it appears like it's not there anymore, but it's just a 1. So we have 9/5 C is equal to F minus 32. But I just want F, right? I don't need the parentheses anymore because nothing is being multiplied in. So now I'm going to do the inverse. I'm going to undo negative 32. So the inverse operation is adding 32. So I'm going to add 32 to both sides. Now I have to be careful here. This is a C term. This is not a C term. They are not like terms, so I can't combine them. So that means the other thing you have to pay attention to is this equal sign. Make sure that you're keeping that equal sign. So this is 9/5 C plus 32 is equal to F. So I have now solved my equation for F. So let's see, what would my degree in Fahrenheit be? So therefore, let's see here, I would do 9/5 times 17 plus 32. That equals to my degrees in Fahrenheit. And when I work that out, it is approximately, well, it is 62.6 degrees Fahrenheit. So 17 degrees Celsius is the same as 62.6 degrees Fahrenheit.